The air system's divided into two subsystems. We have the supply system and the control system. It's important to understand that there's three sections to it. There's the supply, the control, and the foundation. The supply system is simply the supply of air to the air brake system. The control system is the control of the supply of air. And we have the foundation system, which is the wheel end. In overview, we have to have a supply of air. Once you have a supply of air, you can control the supply of air. And once you have control of the supply of air, you can send it to the foundation brake to create a mechanical advantage and stop the vehicle. Shop tip. Always remember, and this is the most important part of any air system troubleshooting or any brake system troubleshooting, air leaks are the root cause for the majority of air system problems. Anytime you've got a problem, always look for air leaks. That's your number one problem. Air leaks are really commonly overlooked. The condition of the supply system will indicate the health of the complete air system. A dirty supply system will result in a problematic control system. You have to make sure the whole system is in good leak-free condition. We need to just kind of highlight on a few things when it comes to the air brake system that are related to the law. We have the Federal Motor Vehicle Safety Standards, referred to commonly as FMVSS 121. Commercial Vehicle Safety Alliance, CVSA, that's your out-of-service criteria, officially known as the North American Commercial Vehicle Safety Alliance Uniform Out-of-Service Criteria. California Vehicle Code, CVC, that's state-specific. Then we have Title 49 of the Code of Federal Regulations that tells you the stopping and all the related requirements for a vehicle in the United States, and Title 13 on the California Code of Regulations, which refers to different sections such as air leaks and things like that. Static air loss is when the service brakes are released and the parking brake is fully applied. That is when the service brake chambers have no air in them and the parking brake or the spring brakes are applied with the spring and have no air in them. Applied air loss is with the service brake fully applied and the parking brake released. Static air loss is a maximum of 2 psi per minute. Applied air loss is a maximum of 3 psi per minute. Now remember, all brake valves and systems leak air. That's just the nature of the air brake system. But air loss in excess of 2 psi per minute static or 3 psi per minute applied is a violation of the Code of Regulations, which will result in a citation for improper maintenance. Actual out-of-service air loss rates are much greater. We want to keep all air loss to an absolute minimum. But sometimes you'll hear little tiny leaks at different valves and connections, and that is acceptable as all brakes do leak a certain amount of air. But no air loss, and it's important to understand, no air leaks at a brake chamber are considered acceptable. Air leaks at connections and valve exhaust ports are acceptable. Air leaks at brake chambers, as I previously said, are in violation of CVSA out-of-service criteria and must be corrected prior to the vehicle being placed back into service. The difference on a brake chamber is if a brake chamber is leaking air, it's impossible to determine if the diaphragm is ruptured or not. Good example is if you do have a leak at a brake chamber, it's out of service, you tighten the clamp, it's no longer leaking, it's now back in service. But anytime a brake chamber is leaking air or there's any leaks at the brake chamber, the vehicle is out of service until the leak is corrected. With the service brakes fully applied, 90% of the air pressure in the brake reservoir must be available at the brake chamber. You can reverse this number and think that the air brake system uses a maximum of 10% of the brake reservoir pressure during a full brake application. This is great for troubleshooting because all you have to do is have your air gauge on the dash At 100 psi, make a full brake application, and the needle should fall to no more than 90 psi. That indicates that we've used 10 psi to fill all the air lines, the brake chamber diaphragm, the valves, and so on. If the needle falls below 90 psi, that indicates we've used more than 10% of the available air in application, and we have less than 90% of the air in the brake reservoir available for braking action. A lot of times this is a good indication of reduced reservoir volume, which is a direct result of contaminants in the reservoir. If the reservoir has not been drained on a regular basis, then you'll find you'll use more than 10% of the pressure in the reservoir during application. You'll have less than 90% of the pressure in the reservoir at the brake chambers. 32 ounces is the maximum allowable limit for liquids in each reservoir. 32 ounces. Remember that and drain reservoirs frequently. Supply system. The supply system provides conditions and stores the compressed air, which is the medium of control and power of the vehicle's braking system. The air supply subsystem is basic to all vehicles. The control system can vary from vehicle to vehicle. If you look at any of your supply systems, you'll find they always have a compressor, a governor, a dryer, reservoir, and different valves. They're basic to all vehicles. The control system, on the other hand, uses different valves to perform different functions. Supply system components. Here's an example of some of the different components that are in the supply system. We have the air compressor, the air governor, air dryer, the reservoirs, we have single check valves, we have a low pressure warning system, safety valve, drain valves, pressure protection valves, regulator valves. Those are all just an example of the supply system components. Air tubing and line colors. Transit buses are unique from over-the-road trucks, and you have to consider the air tubing and line colors as a schematic. It's divided into 6 different colors common to transit bus. Green is the supply and primary brake system. Red is going to be your secondary brake system or the front brakes. Brown is your parking or emergency system, which is actually your spring brakes. Yellow is governor control circuit. Black is your accessory system and suspension system on some buses, depending on the manufacturer. The suspension system is typically blue on some buses, or it could be black. The important thing here is not to mix the colors up, and it's great for troubleshooting. When you look at a valve or you are troubleshooting the system is laid out for you just like a wiring schematic. Green, supply primary brakes. Red, brown, yellow, black, blue. They're all indications of what the lines are. Supplying air or transporting air to operate or for the operation. Keep in mind that the different colors should never be mixed up. When you're troubleshooting your rear brakes, look for the green air line. Front brakes, look for the red, and so on. Now, air lines, for all they do have an outer color, like I just said, green, brown, red, yellow, they also have a white inner layer, so they're 2-ply. It's generally acceptable for the outer color or the outer ply to have some scratches on it. That's not a big concern. If the outer color is worn through, exposing the white inner core, then the line is compromised and must be replaced. When you replace an airline, the generally accepted policy in the industry is to go with the same color, always the same size line that is in the existing system. Now, sometimes you don't have that color. The accepted practice, but try to avoid this and stick with the same colors, is you can use black in place of any of the colors. But all you're going to do then is, although you'll clear the bus for service, you'll make it more difficult for troubleshooting in the system. If you're looking for a green line and somebody's replaced it with a black line, then you're probably going to overlook that line. On the other side, if you're looking for a green line and somebody put a red line in, then you've got it confused with a completely different air brake system. In other words, you're looking for the rear and now it's identifying itself as the front brakes. That's going to create a lot of problems. Try and stick with the same color and definitely stick with the same line, size, and routing.